Now after adding the first layer, we will add another layer of LSTM. So the syntax is same. So I'll just copy the syntax and I will paste it here. And this comment part also I will copy and I will paste it here. And instead of first, I will write here second. As this is a second LSTM layer, so we don't need to give this parameter which is input shape. So I will remove this because we have already provided input in the first layer. So whatever the transform input is passed to the second LSTM layer. So I will remove this part. Return sequences are true and this units also 45 and this dropout is 0.25. So 0.25 means 25% of the neurons are dropped while training in forward and backward propagation. Okay. So this is how we can add the second layer. Now to add the third layer, again the steps are same. Again I will copy this part and I will paste it here. Now this is the third layer. This is the third layer of RNN. The units are 45. It means there are 45 neurons and return sequences are true because we are again going to add one more layer to it. That's why I'll keep it as true. And the dropout is 0.25, which is 25% of 45 neurons. Okay. So out of this 45 neurons, 25% will be dropped while training. Now let's add the fourth layer and some dropout regularization. Here, as this is the last layer, so there will be some changes to it. So this is our last LSTM layer, which is fourth. So this is our fourth LSTM layer with some dropout regularization. So we will remove this part which is return sequences. So this return sequences part will be removed as it's a last layer. And the dropout is same here. Dropout is 25%. Now the last thing is we will add the output layer. Now at the output layer, there will be only one neuron because at that neuron, the output we will get the output at that neuron. So adding the output layer is the last thing. So let's add the output layer now. So take RNN dot add and here we will use the dense layer to get the output and the units are 1. So there are 1 unit. So this is our RNN. We have first initialized our network. Then we added the first layer of LSTM. Then we added the second layer, then third layer and fourth layer. The only difference is that in the first layer you need to provide the input and in the last layer you need to remove the return sequences. And this is the output layer where you get the output and that is the dense layer. After creating the neural network, it's time to compile the neural network now. So let's compile the neural network. To compile the neural network, we need to add 2 things. The first is the optimizer and second is the loss function. So let's compile the neural network, which is RNN. To compile the neural network, first we will take RNN, then we will write dot compile and here we will provide the algorithm for optimization. So we will take optimizer. So there are different optimizers with the help of which you can compile your RNN. So there are ADAM algorithm, then you can try RMS prop, then you can try SGD, stochastic gradient descent. So there are different optimizers. Mostly RMS prop is used for recurrent neural network. So you can try either RMS prop or ADAM or SGD. It totally depends on you. And also it's a part of experimentation. So here I'm going to use ADAM and also I will try this. I will also train my neural network using SGD or RMS prop. Okay, you can try to compile your neural network using these 2 algorithms as well, using these 2 optimizers as well. Now the loss function, as it's a continuous valued problem, so the loss function here is mean squared error. MSE. So write mean squared error. So mean squared error is taken. And the last is, let's fit this RNN to our training set. So this our RNN is now ready. So now let's fit this RNN to the training set. To fit the RNN to the training set, we will take this RNN object and then we will use the fit method. Here first we will provide our data, which is X-train data. Then we will provide the Y-train data, epochs. So it totally depends on your processor as well. How much time will it take to train the data? Because if you keep large number of epoch, then it will definitely take more time to train the data. As well as depending on your processing system, you can change the batch size as well. But if you change this epoch and batch size, then it will definitely affect your training rate, and it will definitely affect the accuracy of the model. So this is how you can create the RNN. Okay. So now I will run this code and it will take pretty much amount of time to train the network. We will understand how to see, how to evaluate this model or how to get the predictions from this model in the next cell. Okay. So now I will press this run button and this training will start, and then I will show you the final output of this RNN. Okay.